I'm recording a Screencastify and on a separate device because I'm not sure you'll be able to see the board really well on the Screencastify. The absolute value of a number is its distance from 0 on a number line. So I have this quick vertical number line here to help us make sense of the number system and absolute values quickly. The absolute value tells us the distance from 0. And when we type it into Google Sheets or a spreadsheet, you would type it in like that, absolute value. Now, absolute value is often notated with these vertical bars. So the absolute value of the negative square root of 2 is the same as the absolute value of the square root of 2. They're the same distance from 0. These distances are the same. I mean, my drawing is not correct, but they should be the same. Absolute value lives in our number system mainly with the integers, I think. I could really, it's in the rational numbers, obviously, the rational number world. But the reason I really pick absolute value to go with the integers is because integers is the first time we get the whole numbers. So the whole numbers are 0 and all the counting numbers. So 0, 1, 2, 3, 4, 5, 6, 7. It's argued, I think 0 should be a counting number. I teach my daughter that 0 is a counting number. What? We have nothing. 0. Okay. But technically, we have adopted the convention that the natural numbers exclude 0. Then the whole numbers add in 0. And then the integers take all of these and flip them on 0. So 0 is like this reflection point, or you could think of it as the mirror, right? Like if I'm looking in the mirror, I'm looking at these cameras. It's the mirror effect, sort of. So integers are the whole numbers and their opposites. So -4, -3, all before -4, -2, -1, 0, 1, 2, 3. And then all this, we still need room for all the pieces in between. And that's where you see the 1.5s, the half, the -half, the -1.5. They haven't filled into natural numbers, whole numbers, or integers yet because they all have parts, fractional parts or decimal parts. In that case, they fall in here. As long as we can actually write a ratio that is equivalent to the value of that number. And in the case of square root of 2 and pi, we have irrational numbers. Now, irrational numbers do not coincide with the complex or imaginary numbers. The irrational numbers are the numbers that cannot be written as a over b, where b doesn't equal 0. Irrational numbers go on forever. They do not repeat, and they do not terminate. So in that case, we have pi, we have the square root of 2, we have the negative square root of 2. And this is where I want to jump over to the imaginary or complex numbers quickly. The square root of -2 is imaginary because the negative is inside the square root symbol. I can think of the square root of 2 as thinking about a actual physical geometric square where each side length is measured 1 unit. And if I want to calculate the diagonal distance from corner to corner across the square, that measurement is the square root of 2. That means that, let's think about this square doubled, because then we can actually play with numbers we're comfortable with. If this is a 2 by 2, then we can figure out the diagonal there, and I challenge anybody else to see, is this diagonal irrational or is it rational? What do you think? And you might need the Pythagorean theorem. So what you would end up doing is taking the square root of 4 plus 4, or the square root of 2 squared plus 2 squared, because we're taking the square root of the sum of the squares of the other two sides of the triangle, which is the square root of 4 plus 4, which is the square root of 16. and the diagonal is 4. So in this case, we have a rational number that's under the square root. Okay, the square root of 2, so square root of 4 is over here because it's equivalent to 2, which is a whole number. It actually goes all the way into the natural numbers. Square root of 2, square root of 4, which equals 2. Thank you, everybody, for your patience. The square root of 2 is irrational because if you actually put that in, you get 1.4142, and it goes on and never repeats. Okay, so this was a quick video about absolute value related to ratios. Let's dive a little bit deeper to see where it comes into play with ratios. I use this fancy word opposite. Now, opposite is just 3 and -3, 2 and -2, 1 and -1. And if you took a ratio of their distances from 0, it would be equal to 1. So the ratio of the distances of, say, let's say 2 and -2, they both have an absolute value of 2. And if I took a ratio of the distance of 2 to 0, it would be 2. To the quantity of -2's distance to 0, it would be 2. And it would be a 1-to-1 relationship. So any opposite number and its original number have a 1-to-1 relationship of their distance from 0. That could be a way we could use ratios. The opposite of 0 is, well, 0. I mean, the opposite of 0 doesn't have a negative. There's no -0. The absolute value symbol are these two vertical bars. They act as grouping symbols, so that takes us into sort of expressions. But the reason why we really need these tools beyond this little connection of ratio is that we need square roots and absolute values and ratios for almost every statistical analysis. So I wanted you all to get a chance to see the real number system. That's the not real number system, so I should group this in here. Rational numbers are real. Irrational numbers are real. Complex or imaginary numbers are not real. Okay, on to the next one.